Dear students, in this session we will discuss about the refraction of light. So when we consider the refraction, as you know by the definition, this is nothing but the path deviation, that is deviation of light when it travels from one medium to another medium. Now let us consider this is the slab A, B, C, D. This is the slab and this is the actual glass slab. Okay, this is glass slab and it is picturized like this. Do you understand? Right. Now what we have to do is you have to take, it's a kind of activity. You have to take a drawing board, affix a white sheet or white paper, drawing paper, and on which you have to fix the glass slab and make a rectangle like this. Okay, so you have to draw like this, right? Now after that what you have to do is you can draw at any angle an incident light. So on the incident light what you can do is you can select 2 points. Let me consider here, that is E and F. So where I can fix the ball pin like this, you know, the ball pin. So it will be like this. So you can let me do the same drawing here. Do you understand? So I can fix the ball pin. This is the ball pin on the whiteboard. We can fix like this. So we can represent this E and N. Now what we have to do is you have to view from here. Okay, you have to view from here, and that is, instead of this light coming straight, there will be a path deviation, and you can that is straight away you can select another 2 ball pins and fix at the G and H. Ensure that it should be almost in a straight line, but it would have been deviated. But when you see from this side, it will be almost collinear. Okay, so you can fix like this, and this is the point GH. Then you can remove it, and you have got already drawn this rectangle. Now you can have a vertical line, that is the normal, and this is another normal. You know very well, this is the medium air, this is glass, and again this is glass and this is air. Okay, now you can draw a vertical line and another vertical line. So this N vertical line and the M vertical line, they are called the normals. So N and M are normal. Normal means what? That is perpendicular to the refracting surface. Which is the refracting surface? AB is the refracting surface. CD is another refracting surface. Now the light travels from what? That is E to F and goes via, that is O. It gets refracted. Instead of going straight, there is a refraction. So since it travels from rarer, air is a rarer medium, rarer to denser medium, there is a path deviation towards the normal. Do you understand? So you know very well, the angle of incidence is nothing but the angle subtended by the incident ray. Which is the incident ray? EF is the incident ray. So this EF incident ray makes an angle I1, that is the incident angle or angle of incidence in the first refraction. So there are 2 kinds of refraction. First refraction is from air to glass, that is rarer to denser medium, and that is why it is getting refracted towards the normal. Now in the second refraction, it is traveling from glass to air, that is denser to rarer medium, so it goes away from the normal. Do you understand? So this should be indicated as R2. This is the emerging angle. And what about this? This is I1 and this is R1, and similarly this is I1, this is I2, and this is R2. Do you understand this? So this is the way we have to draw this picture. Okay, so make sure that the arrow mark, everything should be very neat. Okay, right. Now let us discuss about the law of refraction. We can check it up here. So we can measure the angle, is it not? So what is the angle of incidence? I1. Angle of incidence of the first refraction, I1. Angle of refraction of the first refraction is R1. Similarly, I2, R2. Are you able to follow? Now based on that, we can that is verify the law of refraction. That is, the incident ray, refracted ray, and the normal all lie in the same plane. Is it not? So all lie in the paper only. That is XY plane. You can make it as a paper plane, plane of the paper. Okay. So incident ray, incident angle, and the normal, everything on the same plane only. Then, according to Snell's law, that is sine I by sine R, sine of angle of incidence. So, what do you call it? Sine of angle of incidence. So, sine I by sine R, sine of angle of refraction is equal to, that is mu. Mu is nothing but refractive index. What is that? Refractive index. Refractive index. Okay, so according to Snell's law, the ratio between sine of angle of incidence and the sine of angle of refraction is always a constant, and that is given by refractive index of the material of the medium. Okay, so it is a material property. So you can represent like this. For instance, mu 21 is equal to speed of light in medium 1. So first medium, second medium. So what is this mu 21, which is nothing but refractive index of the second medium with respect to first medium. So you have to read like this. So what is mu 2? That is, it is the refractive index of the second medium with respect to the first medium. So in that case, it is a V1 by V2. That is the speed of light traveling in medium 1 divided by speed of light traveling in medium 2. Okay, so V1 by V2. So similarly, mu1 2 means refractive index of the first medium with respect to second medium. So in that case, the speed of light in medium 2 divided by speed of light in medium 1, that is V2 by V1. Do you understand? Right. Now, let us move to the next. So I hope now you should be able to understand the refractive index, okay, and what is Snell's law and what is this activity, okay, right. Now let us move to the next concept, dispersion of white ray. You know very well that is when the white ray is dispersed, it becomes a VGR. So we need to prove that. So let us take a glass prism. So in this glass prism, you know very well about the glass prism, it is a triangular, is it not? So when white light comes like this, it is getting refracted and dispersed into big G or violet, indigo, blue, green, yellow, orange, red. So when white light passes through the medium, prism, it is split into the band of 7 colors, that is called VGR. Is it not? And that is called the dispersion, the splitting of white light into component color. When it is passed through the glass prism is called dispersion. So what is dispersion? It is the splitting phenomenon of white light when it is passed through what? The glass. So what it becomes? It becomes a component of colors, that is VGR. So different colors refract at different angles, that is to be noted. Then violet is much refracted. So violet, you can observe here, violet is much refracted than red. Is it not? The red is the least refracted one. Okay. So based on that, you can see the number of properties, natural properties. Now, when white light is passed through, okay, through two identical prism are joined like this. Okay, so when white light is passing through, what happens? It is getting dispersed. So after that, once again it is refracted, you are able to get what? White light. So it is one of the evidences that the white light consists of, that is, 7 colors. We understand? Right. So this is called double refraction.